Let's try some more examples. And let's write our formula first. A plus b quantity squared. And we can always convert it back and forth from factored form into the expanded form if it's a perfect square trinomial. So expanded form, a squared plus 2 times ab plus b squared. Be aware, this is not your quadratic equation style, okay? It's just your perfect square trinomial format. For our first example, we have x squared plus 10x plus 16, and the question is this a perfect square? And if it is, we'll try to factor it. That way you can see that it's very straightforward once you figure that out. So is it a perfect square trinomial? Let's see. We have the a squared. That would be x squared is the a squared. So we know a has to be x in this case, or you can put a 1 in front of it to make it a 1x. And b, 16. Let's see, what number squared gives us 16? That way we can make it into a b squared. Let's see, 3 times 3 is 9. Nope, that's a little undersized. 5 times 5 is 25. Nope, that's a little too high. So 4 times 4 gives us 16. Agreed? So 4 times 4 is 16. So therefore our a value, x squared, or you can put a 1 in there in front of it and say a 1x squared. And our v value seems to be 4. Or we can call it b squared, or 4 squared in this case. Therefore, our middle term is a combination of our a and b values. So it will be 2 times the x times the 4. So there we go. 2 times a times b, 2 times x times 4. And let's realize 2 times 4 gives us 8, so there it is. Okay, so x squared plus 8x plus 4 squared. Hey, does that middle term look like the same as what we started with? Hey, 8x is not the same as 10x, agreed? So therefore, in this case, it's not the same. So it's not a perfect square trinomial. If we would have gotten 10x, then we would have said, yes, it's a perfect square trinomial. So not the same as what was given. This is definitely not a perfect square. So we cannot factor it as a perfect square then. Can't do anything in this one other than try to factor in a different format. Keep in mind, there's other formats of factoring, but for this case, we're trying to do it through perfect square trinomial format. So let's go for the next example. X squared plus 10x plus 25. Is this a perfect square trinomial? If it is, we'll try to factor it. Let's see. Our a value could be the x. Well, technically it's the x. We could put a 1 there if it helps as well. 25. What number squared gives us 25? We sort of mentioned it earlier. Agreed? So 5 times 5 will give us 25. So 5 squared would be the v value then. So a value, x. X is our a value, and then we square it. And therefore 5 is the v value, and we're squaring it. Middle term would have to be 2 times a times b. So 2 times the x times the 5. And 2 times 5 gives us 10, agreed? Hey, look at that. We get the 10 from the middle up above. So x squared plus 10x plus 5 squared. So the middle term is the same as what we started with originally. There it is, visual representation. Now we can see it as the same. So therefore this is a perfect square trinomial. And realize that's it. We've technically almost factored it. All we're missing is realizing that our a value is x, our v value is the 5, plug it into your factored formula. So in parentheses, x plus 5, close your parentheses, and squared. That's it. You're done factoring. Can you believe it's that fast when it's a perfect square trinomial? So there's your answer. Let's try for the next one. Hey, 25x squared minus 9. However we try this one, it's not going to be a perfect square from what we can notice. It's missing your middle term technically. So definitely would not be a perfect square in this case. So what could we do? What does that look like? Hey, we may have seen in the past difference of two squares. If you haven't seen them, difference of two squares, I'll rewrite the formula down here. Now you can see it. Difference of two squares means a squared minus v squared. And we can factor into two sets of parentheses, similar to perfect square trinomials, but they become a one set of parentheses in the end. On the other hand, difference of two squares do not become one set of parentheses. They're two separate set of parentheses. And that's because you end up with a plus and a minus in the parentheses. Be aware of that. It's slightly different, hence the reason why I'm going over it. That way you can realize that it's slightly different than the perfect square trinomials. So, as the example that we have, let's write it down, 25x squared minus 9 squared. And let's realize the 25x squared does not exactly look like a squared. And 9 squared, whoops, That should have been 3. So that should have been 3 squared. Be aware of that, okay? So we have 5 squared. We can convert that 25 into a 5 squared. And that 9, well, it'll be 3 squared. Kind of got ahead of myself on there. Shouldn't have a square at the beginning there. So let's realize that we can factor a square from both the 5 and the x. So it becomes 5x quantity squared minus 3 squared. And we technically have the a and b value. So the a value, 5x, and let's write it in its respective location in the set of parentheses. And the v value is therefore the 3. Notice it does not include the negative sign or the square on it. So it's just the 3 by itself. Agreed? And there it is. There is our full factor form via the difference of two squares. Other than my minor error there, which is the square on the 9. There shouldn't be a square on the 9. Let's get rid of the square on that 9. So there we go. There is our fix. It's 25x squared minus 9, our original statement. We essentially converted into a 3 squared, and the 25 we converted into a 5 squared. And we separated the squares from both the 5 and the x to make it look like the a value. The parentheses, 5x, implies that that's our a value. Hence the reason why we plugged it in for our a value into our set of parentheses. So once again, did you notice the difference between perfect square trinomial factoring and difference of two squares factoring? Significant difference, agreed?